Good day, students. My name is Iwalewa Matthew. I'm still here to take you mathematics. Before we proceed to today's work, in our last class, we look at trigonometry 1, whereby we look at the basic trigonometrical ratios, which are sine, cosine, and tangent. We also look at their inverse, which is the reciprocal of these trigonometric ratios, which are cosecant, secant, and cotangent. We also look at the value of the trig ratios. We look at sine 30, 45, and 60. We also look at cos 30, cos 45, and cos 60. And we also look at tan 30, tan 45, and tan 60. And we also discuss the relationship between sine and cosine, where we said these two trig ratios are complementary in nature. Sorry, which means they are their sum, which means sine 30 will be equals to cos 60 degrees because they are complementary angle. Today we shall be going to trigonometry 2, and under it we shall be looking at application of trigonometric ratios, which is with the use of angle of elevation and depression. So we want to look at the application of these trig ratios. Now, secondly, we also look at the angles between theta and 360 degrees. And under the angles between 0 and 360 degrees, we shall be looking at the general angle and trigonometrical ratios for theta greater than or equal to 0 degrees and theta also less than or equal to 360 degrees. So let's start with angle of elevation and depression. So you can see, when we are talking of angle of elevation simply means, let me use a simple English whereby you can understand. When you stand upright and you focus to the front view whereby you are looking straight, for you to look straight when you are standing, let me give you an instance. Assuming you are standing here, this is where you are standing, so it means this will be your sight, that is, you are looking straight. So once you raise your head up and look at the sun, then this angle is called the angle of elevation. And that's why you see the angle formed with the horizontal. When an observer look up, you can see this is the horizontal, this is the horizontal line, and this is when you look up. So the angle it forms with the horizontal is called angle of elevation. When the angle of depression is when you are at the top of a particular building, assuming this is a building now, and this is the ground level where the house is built on. So it means that this is the house. Now, if you are standing at the top here and you are looking at a dog down here, this angle is also called the angle of depression, where this is your horizontal level. You can see this will be your horizontal level because this will be the direction of your eyes. But when you set your eyes down, that will now give you angle of depression. So the angle formed with the horizontal when an observer look down is called angle of depression. So that is what we mean by angle of elevation and angle of depression. So here, alpha here, you can see this angle. This angle is angle of elevation, and this angle is angle of depression. So now let's start with examples on angles of elevation. Example 1. The angle of elevation of a point P on a tower from a point Q on the horizontal ground is 60 degrees. You can see this is the horizontal ground, and you see the angle it forms, which is 60 degrees. Now, if line PQ, this side is 74 meters, how high? So it means we are looking for the height of the tower. So for us to look for the height of the tower, when you look at it very well, this is my right angle triangle. So now this will be my hypotenuse. Sorry, this will be my opposite because this is the given angle and this is where the angle is facing. So this will be my opposite, which will give me OPP, shorting. And this is the right angle, which is facing 74, where 74 will be my hypotenuse. Then the third side here down will be my adjacent. So it means in this diagram, I have my hypotenuse and opposite. So using the acronym SHOCATUA, which is SOHCAHTOA, using the acronyms, which of the sign, the trig ratios have opposites and hypotenuse? That is sine, you can see. So I told you that sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is opposite over adjacent. So it means sine is the one having this trig ratio. Now, so the relevant side is 60 degrees. You can see that this is 60 degrees, and opposite and hypotenuse, which is so. So it means I'm looking for the opposite, but I'm given the hypotenuse, and I'm given the angle facing the opposite. So that's why I'm using sine of angles, which is sine theta is equal to opposite over hypotenuse, where my theta is 60 degrees. So here I have, from this step now, I have sine 60 degrees is equal to opposite, which is x, over hypotenuse, which is 74. So here, cross multiply from here, this is over 1. So here is x times 1, which is x. Or I can first look for the value of sine 60 degrees. Don't forget, from the trigonometric table that I gave you in the last class, I told you that sine 60 degrees is still the same thing as root 3 all over 2. So here sine 60 is root 3 over 2. So it means this sine 60 is the one that gives us this root 3 over 2. Then equals to x over 74. Then you can cross multiply from here. You can cross multiply. So this is 2 times x, which is 2x. 2x is equals to, then what do I have again? Then 74 multiplied by root 3. Multiplied by root 3. So from here, I can divide both sides by 2. Divide both sides by 2. So 2 here cancel 2. I'm left with x is equals to 2 here, 1. 2 in 7, that is 3. Remainder 1 in 14, that is 7. So it means here I have 37 times root 3. 37 times root 3, which will give us 37 root 3 in meter. So that will give us 37 root 3 in meter. Exactly, that's the same thing we did here. So let's continue. Example 2. A man 1.8 meter tall observed a bird on top of a tree. If the man is 21 meters away from a tree and his angle of sighting the bird is 30 degrees, calculate the height of the tree. So here, when you look at this diagram very well, it means a man 1.8 meter tall. If the man is 1.8 meter tall, assuming this is the man, which is 1.8 meter tall, observe a bird on a top of a tree. You can see. So if the man is standing here, it means the sight of the man will be here. So it means that this is the horizontal. So the man now observe a bird at a tree. If this is the tree, this is a tree. So it means this is the angle of elevation of the man, which is 30 degrees. Now, don't forget the man is 1.8 meter tall. Now, and the man is 21 meter away. This is 21 meter away from where? From the tree. So it means the distance between the man and the bottom of the tree is 21 1. You will now look at this diagram very well. If I carve it out now, it means this is the man standing, this is the tree. It means the tree is taller than the man. Now, if the man is standing here, it means this will be the side of the man. Then this will be the angle of elevation. It means the bed is here. So this is angle of 30 degrees. And this is the distance between the man and the tree, which is 21 meter. Same thing, the height of the man is 1.8 meter. Now, if the man is 1.8 meter, you will now notice that 1.8 is not part of the workings here because it's not in the diagram. But if I want to look for the height of the tree, it means the height of the tree will start from the bottom to where the bed is. So automatically, I know this from here to here to be 1.8 meter, just for me to look for this side. So look for this side, which is x, then add it to 1.8. Now, this is my opposite, which is x. This is my hypotenuse, because this is a right angle. Then this is my adjacent. So it means I have opposite and adjacent. And when you look at your trig ratio, the side having opposite and adjacent is tan, which is tangent. So here I'm using tangent. Tan 30 degrees is equal to opposite, which is x, which is represented as k here, then over the adjacent, which is 21. So here we just cross multiply. That will be k is equal to 21 times tan 30 degrees. And the value of tan 30 will give you, when you press that on your calculator, tan 30, that will give you 0.5774. Then multiply it by 21. That will give you 12.1254 degrees. Now approximate this to the nearest hundredths. So it means you leave two numbers at the back of the point. So that will give you 12.12 meter. Now, the height of the tree will now be decay. You know, I told you at the beginning that if this is the height of the tree and the man is standing here, it means this will be the eye level of the man. Then the angle of elevation is here. So it means 1.8 is already here, which is the height of the man. So the remaining distance between the man and the bed, that is x. So I've gotten my x here to be, which is k, to be 12.12 meter. Then add it to 1.8. So that will give you 13.92 meters. So the height of the tree will be 13.92 meters. So let's go to angle of depression. That is on angle of elevation. Now let's move to angle of depression. Example 3. We stop at example 2 there. Then example 3. A boat can be sighted at the sea 71.5 meter from the foot of a cliff, which is 26 meter high. Calculate the angle of depression of the boat from the top of the cliff. Correct to two significant figures. Now, when you look at this question very well, this is the boat is here. You can see it's already labeled. The boat is here. So it means if this is the top of the cliff, this will be the base, which is the foot of the cliff. Now, a boat can be sighted at the sea, which is 70. It means the boat is 71.5 meter from the foot of the cliff. So if this is the foot, this is the boat. The distance between the boat and the foot of the cliff is 71.5 meter, which is, and the distance between the foot of the cliff and the top of the cliff is 26 meters. So it means I'm given the opposites and adjacent. Now, if this is my angle theta, you know, we discussed it in our last class, that if this is theta, this angle too will be theta, which is our corresponding angle. When you look at it very well, it forms a Z angles. And Z angles are alternates. So, if this angle is theta, definitely this angle too will be theta. So, the question now says calculate the angle of depression. So, once I get this angle, I already get this angle. So, for me to look for the angle now, I will check the side that I'm given. So here I'm given my opposite, which is 26, and I'm given my adjacent, which is 71. So when you look at the trig ratio that speak about opposite and adjacent, that should give us tan, which is opposite, which is 26 over 71.5 meter. And when you take your calculator and divide 26 by 71.5, so you get 0.3636. So if you want to get your theta, that will be theta is equal to arctan 0.3636. So you go to the tangent of angles. Go to the tangent of angles. Look for the value, the number that will give you 0.3636. So it means go and check your four-figure table. Check tan 19 under 9 difference 8. So when you look for that, it will give you what? It will give you 0.3636. So the question says you approximate to the nearest two significant figures. So if I have 19.98, so this is 1, 2. This is that two figures. Then round this one up to 1. Then 1 plus 19, that will give me 20. So it means the theta is 20 degrees. So it means the angle of depression, which is this angle, is 20 degrees. Once this angle is 20, this angle too will be 20 degrees. Now let's now move to the second part, which is the general angle. This is where we are still going to learn another trigonometrical ratios. And this general angle here deals with a quadrant. So the Cartesian axis OX, looking at this Cartesian axis OX, the Cartesian axis OX, this is O at the middle and this is X, and OY. You will see it gives you a right angle, and it divides this into 4 equal parts, where we have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So you can see here, this angle is read in an anti-clockwise direction. So you can see the angle, the quadrant is moving backward. So this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Are we getting it now? Now, within the axis, an angle may be declined as an angle may be measured. An angle may be defined as a measure, an angle may be defined as a measure of the rotation of line OP. Now this is where we are going to start the explanation, which is, you can see that we have line OX in our first page. Now we have line OP1. We have line OP2. So it means an angle can be measured in these two directions. When you look at OP1 is moving in an anti-clockwise direction, and when you look at OP2, OP2 is moving in a clockwise direction. Now, let me now tell you something that is not written here now. When you are measuring angle in a clockwise direction, it will give you a negative angle. And that's why you see, you have, when you look at the arrow, you see that what is there is negative angle. But when you are measuring angle in an anti-clockwise direction, the angle will be what? Will be positive. So it means if I have 0 to be here, and when you look at this, this will be 90, this will be 270 degrees, sorry, this will be 180 degrees, this will be 0, 90, this will be 180, this will be 270, and this will come back to 360 degrees. Now, when you move from here to 90 degrees, that will give you plus 90 degrees. But when you move here, it will give you minus 90 degrees. So when you rotate or read an angle in an anti-clockwise direction, it will give you positive angle. And when you move it in a clockwise direction, it will give you a negative angle. So angle may be measured clockwise or anti-clockwise from the origin, which is from the center. Now, in the figure below, looking at this figure now, this diagram, plus 60 degrees is measured from OX. When you look at this is X, this is Y, this is O at the middle. So when you look at it, if I bring an angle here, so it means if I read backward, that is positive. So that will give me plus 90, plus 60 degrees. I told you earlier that when you move or read an angle in an anti-clockwise direction, that will give you a positive angle. So when I read this angle now from here to OP, that will give me plus 60 degree. But do you know that if I move that angle from here back to here, that will give me a negative angle? So if from here to here is already plus 60 degrees, if this already give me plus 60, and the sum of the angles of this rotation is 360 degrees. Now, I've removed this angle to be 60. It means the remaining angles will be 300 degrees. But now, because I'm reading it in a clockwise direction, that will give me negative, which is minus 300 degrees. So here I can say that plus 60 degrees here is also equals to minus 300 degrees. Why? Because they are equal. Because their sum still give us 360 degree. And that's what you can see in the next line. It said thus plus 60 degree is equals to minus 300 degrees. So adding or subtracting a full rotation of 360 does not affect the final position of AP. So it means if I also subtract this 60 from 300, 60 from 360, it will still give me minus 300. So the position does not still change. It still falls in the first quadrant. So when you look at it, minus 300 degrees and plus 60 degrees, they still falls in the same quadrant. Same thing happens if I have minus 270 minus 270. So if I have minus 270, that still falls in the what? In the second quadrant, because this will be 90, this will be 180, this will be 270 degrees. So with the opposite angle, I will still have the same value. So the addition and subtraction does not change the position of the OP. And the position of 60 degrees is still the same thing as 300 degrees and 420 degrees. That is, when you add 360 to 60, don't forget we have plus 60 degrees before. So if you add 360 to it, so it will still give us 420 degrees. So it still stands at the same quadrant, which is the first quadrant. So example 1 now. Which quadrant does P lie in, given the angle between OP and OX is 150 degrees? Now I'm given 150 degrees. I'll first go and locate where I can get 150 degrees using my quadrants, because the question says which quadrant. So I know that I already have first quadrant, second quadrant, third quadrant, and my fourth quadrant. Now, from here to here is 90 degrees. And from here to here is also 90 degrees. So which is 180, which is more than 150 degrees. So the best thing I will do here is to subtract 150 from 180, because from here to here is 180. Then subtract this 150 from 180 degrees, so that you can know the remaining angles. So it means if I add 90 plus 60 degrees, so it means I'm going to remove 60 degrees out of this 90. And that's why you see we have two angles here, this and this. This angle here is more than this. Why? Because this is 60 and this is 40. So if I add 90 here plus the remaining 60 here, it gives me 160. So it means my OP is lying here, which falls in the second quadrant. So it means my plus 150 degrees will fall in the second quadrant. Then the B, that is minus 120. Don't forget, I told you that when you want to get to 120, you read in a clockwise direction. Once you want to look for a negative angle, you start from the origin, which is from x, which is 0, from this. Now, from here to here is 90. So what will I add to 90 to give me 120 degrees? So that is 90, 100, 110, 120. That is 30 degrees. So you can see that that's why I'm bringing out 30 degrees from these quadrants, which is 1, 2, 3. So it means minus 120 degrees falls in the third quadrant. So minus 120 degrees is in the third quadrant. Also, if I give you 289 degrees, 289. So don't forget, from here to here is 90, 180. You can see it's not up to 200. This is 270. Then 280 will fall in the fourth quadrant. So 240, 298 will fall in the fourth quadrant. So it means in the first quadrant we have numbers between 0 to 90. In the first quadrant here. Second quadrant here we have between 91 to 180. The third quadrant we have from 181 to 270. Then in the fourth quadrant we have 271 to 360 degrees. So any number between 0 to 90 will fall in the first quadrant. And in the second quadrant, any number between 91 to 180 will fall in the second quadrant. Then between 181 to 270 will fall in the third quadrant. Then in the fourth quadrant, that will be 271 to 360 degrees. So example 2 now. Find the positive angle between 0 degrees and 360 degrees, which is equivalent to the following angles. So here I'm looking for the positive angles. So in the first example there, we look at the quadrant in which the numbers lies in rather. But in the second example, we are going to look at the positive angles, where we have both negative and positive angles. Now, in the first one, we have plus 610 degrees. When you look at your quadrant, you will see that your quadrant is not up to 600. Your quadrant stops at 360 degrees. So, and the next thing for you to do is to reduce these 610 degrees to the simplest form. So what will you now do? The best thing you do is the sum of your quadrant is 360 degrees. Then subtract that 360 degrees from 610. So the remaining angle is 250 degrees. You can see that the remaining angle is not up to 360 degrees. But assuming the remaining angle is more than 360, you still subtract from 360 degrees. But once it is not up to that, then it means the positive angle that is equivalent to 610 degrees is 250 degrees. So you just subtract 360 from 610. It depends on the value you are given. Because I'm giving a positive number here and it's greater than 360, that's why I'm subtracting. But look at example 2. Example 2, I have minus 60 degrees. You will see that this is a negative angle. So for me to get a positive angle, it means I have to add. And when I want to add, I will also add 360 degrees to minus 60. So you owe me 60 and you have 360 with you. So if you pay 60 out of the 360, that will give you plus 300. So it means minus 60 degrees is also equivalent to what? To plus 300 degrees. Then the C, I still have negative, which is minus 150 degrees. So here, if I want to have a positive angle, the best thing to do is to also subtract 360 degrees, to add 360 rather, to minus 150 degrees. Don't forget, if I subtract 360 from minus 150, it will still give me a negative angle. But the instruction says I should find the positive angle. So whenever I'm given a negative angle, I will add. And whenever I'm given a positive angle, I will subtract. So that is exactly what we did here. So in example D, you can solve it like this. You see that 720 degrees is more than twice of 360 degrees. So what I did here is I now multiply 360 by 2, which gives me 720 degrees. You see that it's not up to 760. And if I want to do it the same way I've been doing example A, B, and C, I can still do it the same way. That will be 720 minus 360. And when you subtract 760 minus 360, that will give you 400. You can see that the remaining value is still more than 360 degrees. So I will still subtract 360 from it again, which will now later give me 40 degrees. So 760 degrees is still equivalent to what? To 60 degrees. So that is for positive angle between 0 degrees and 360 degrees. Now, let's now go to trigonometric ratios for theta greater than or equals to 0 degrees and theta also less than or equals to 360 degrees. This is the last phase of the trig 2. Now, this is the explanatory of this quadrant, which I've been explaining at the beginning. So you can also see that here we are sitting with the quadrant, and there we are going to look at another trig ratios apart from our normal sine 30, sine 40, and sine 60, sine 90, or sine 45, and so on. Now, the figure below shows a Cartesian plane divided into its quadrant, into 4 quadrants, which is what I've explained earlier. Within each quadrant is written those ratios which are positive. Now, it shows that when we are talking of this quadrant, when you look at the beginning of this work, we just look for the number. We say when you did an angle in a clockwise direction, that is negative, anti-clockwise direction, that is positive. But here, there are some of these trig ratios that once they fall in 1 or 2 quadrants, their signs change. For instance, now, in the first quadrant, this is showing the first quadrant, it means that both sine, cos, and tan are all positive. So it means in the first quadrant, if you have sine of angles between 0 to 90 degrees, so that is what this set building notation means, that theta is greater than 0 degrees, which is any number that is greater than 0, that is starting from 1, and theta is also less than 90 degrees. So it means any number between 0 to 90 degrees in the first quadrant here, either it is sine, cos, or tangent, will be positive. So if I'm given sine 45 now, sine 45 will be in the first quadrant, and all the trig ratios are what? Are positive. So you can see in the first quadrant, all the ratios are what? Are positive. But in the second quadrant, only sine is positive. So if sine is positive here, it means cos and tan are negative. Cos and tan are negative. So it means if I have between 90 degrees and 180 degrees. So if I have sine 100 degrees now, sine 100 degrees. So sine 100 degrees will give me plus, because 100 degrees falls in the second quadrant. And when I look at for the trig ratios in the second quadrant, which is sine is what? Is positive. So sine is what? Is positive. So it means sine 100 degrees is positive in the second quadrant. But if I'm given cos 100 will be negative. Why? Because cos is negative in the second quadrant, and 100 falls in the what? In the second quadrant. So in the second quadrant, only sine is positive, then the rest of the trig ratios are negative. Then in the third quadrant, only tangent of angle is positive, while sine and cosine are what? Are negative. And the number that between that is theta is greater than 180. That is numbers between 181 to 269. So theta is greater than 180, but it is less than 270 degrees. So that is between 0 between 181 to 269. So, but only tangent is positive, while sine and cosine are negative. Then in the fourth quadrant, only cos, which is cosine, is positive, while sine and tangent are what? Are negative. And that is between numbers between 271 degrees to 360 degrees. Now, there's a short formula in which you can use to remember these trigonometric ratios. For instance, look at their first letter is represented. If I have A, C, T, S, which is arts. So it means that in first quadrant here, all signs are positive. Fourth quadrant, only cos is positive. Third quadrant, only tan is positive. And in second quadrant, only sine is positive. So for me to, if I want to remember this is the logic I do use. So once I draw the first four quadrants, I just start with A, C, T, S. So with this, I already know which of the trig ratios is positive and which one of them is what? Is negative. So, and that is exactly what we have here. When you look at it very well, we have ACTS. And some use it as SACT, SACT, SACT. And some use it as CAST. If you want to use CAST, that will be, you start with the fourth. That will be CAST or ACTS. Anyhow. So you just pick the one, but don't be mistaken. Don't be mistaken. If you put another trig ratio in another quadrant, you have already missed the whole question. So that is why you must look for a way to know one of these. Is either you know this A, C, T, X, or you know this, which is C, A, S, T. With this, is very simple. So the first quadrant is A, all signs are positive. The fourth quadrant, cos, where only cos is positive, it means the rest are negative. Then in the third quadrant, only tan is positive, the rest are negative. Then in the second quadrant, only sine is positive, the rest are negative. So that is exactly what this diagram is showing, is indicating in the below it. Then we have two examples. So example 1, express the sine, cosine, and tangent of 60 degree, 120 degree, 240, 300 degrees as either positive or negative trigonometrical ratios of an acute angle. Now, when you look at the example very well, I have to know which quadrant the numbers falls in. Then after getting the quadrant, then I will decide if that trig ratio is positive or negative. So for instance now, the number 1, which is 60 degrees. If I want to look at 60 degrees falls in the first quadrant. And don't forget, if I want to use that acronym, that is what? That is A, C, T, T, S. So I have A, C, T, S, where all signs are positive in the first quadrant. And that's why when you look at the solution to the number A, you see that in the first quadrant, sine 60 will be plus sine 60 degree. Why? Because it is positive. And same thing, cos 60 degree will be what? Will be plus 60 degree. Why? Because cos is also positive. Then tan 60 degree will also give us plus tan 60 degree. Why? Because tan is also positive in the first quadrant. And you will notice that this angle is an acute angle, because it's from the instruction that we should either be positive or negative trigonometric ratio of an acute angle. So I don't need to subtract anything from here. But when you look at the number 2, that is 120 degree, and 120 degree is not an acute angle. But before I can change that to acute angle, I will first look at which quadrant 120 falls to. Now let me go back just a step. Looking at this quadrant here, this diagram here, you will notice that in the first quadrant, we have 90 degrees is greater than theta. So it means whenever you have an acute in quadrant, first quadrant, your angles are acute. Why? Because they are less than 90 degrees. But in your second quadrant, you will see that your angles is greater than 90 degrees, which is an obtuse angle. So if you want to reduce it to an acute angle, the formula is already given there, which is 180 degree minus theta. And that's exactly what I will now use to answer this question B. Because I have an obtuse angle, which is 120 degrees. So 120 degrees falls in the second quadrant, because that is 190 plus 30 degrees. So it is this small angle here is 30 degrees, then plus 90 here. The sum of the angles give me 120 degrees. So in the second quadrant, sine, don't forget my trig ratio. My trig ratio, the first thing you are going to do is to first draw your trig ratio. Then this is ACTS. So it means in the second quadrant, only sine is positive. And that is why you see sine 120 degree will be plus sine, open bracket, the formula there is 180 degree minus theta, where my theta is the angle given to me here, which is 120 degrees. So that will give me 180 degree minus 120 degrees, which is 60 degrees. So that will give me sine plus sine 60 degrees. Now, if I want to look for the angle under cos, so cos is negative in the second quadrant. So that will still give me cos minus cos 60 degree. And tangent is also negative, because since sine is the only positive trigonometric ratios, the others will be what? Will be negative, and they will give us the same value, which is 60 degrees, and 60 degrees. So in the second quadrant, I will have plus sine 60 degree minus cos 60 degree and minus tan 60 degrees. So let's go to the C, which is 240 degrees. And when you look at 240 degrees falls in the third quadrant. So in the third quadrant, sine, what is positive there? That is only cos. Only tan is positive in the third quadrant. Only cos, only tan rather. Only tan is positive. Looking at our trig ratio, which is ACT, you can see this is the third quadrant where only tan is positive. So it means that will not be, and don't forget, and the formula there is theta minus 180. So what I'm given there is 240, which is theta, minus 180 degrees, which will give me 60 degrees. So sine will now be minus sine 60 degrees, and cos 240 will be minus cos 60 degrees, and tan will be plus tan 60 degree. Why? Because only tan is positive, where the other trig ratios are negative. Then the last example, we have 300 degrees. So, and when you look at 300 degrees falls in the fourth quadrant, where cos is only positive and the other trig ratios are negative. And the formula there in the fourth quadrant is 360 degrees minus theta. So my 360 degree minus theta is 300. So that is 360 minus 300, which is 60 degrees. Where sine is negative, that will be minus sine 60 degree. Then my cos is positive, which is plus cos 60 degrees. And my tan is negative, which is minus tan 60 degrees. Then example 2, which may be the last example for today's class. Evaluate the following: cos 160 degree, B sine 137 degrees, C tan 251 degrees, D minus sine minus 58 degrees, E tan minus 145 degrees, and F cos minus 33 degrees. So to solve this question, we still use the same formula since the question says you should look for the values of this. And when you check your four-figure table, you cannot see cos 116 degrees because it's not up to, the cos of angle is not up to 116. So it only stopped at 99 degrees. So the best thing for me is to first reduce this. But if I want to reduce it, I will also look at the trig ratios and the sine. So cos 160 degrees falls in the second quadrant. So you can see that is what I wrote here, that cos 116 degrees falls in the second quadrant, where the formula is 180 degrees minus theta, and my theta is 116 degrees. So 180 minus 116, that will give me 64. And cos in the second quadrant is negative. So when you look at the first example, you will see that the first example, you are not given you are not given the value, the cos, either the trig ratios. But in this second example, you are given the trig ratio. So here you look for the trig ratio, the sign is negative, which is minus cos 64 degrees. And when you look for cos 64 degrees, that will give you 0.4384. So that will give us minus 0.4384 from tables, from the four-figure table. Then the example B. In example B, we have sine 137 degrees. Under sine 137 degrees, we have sine 137 degrees. So 137 degrees falls in the second quadrant as well. 137 degrees falls in the second quadrant. So, and the formula there is 180 degrees minus theta. So subtract 137 degrees from 180 degrees. That will give you 43 degrees. So in the second quadrant, sine is positive. So that will give you plus sine 43 degrees. And go and check your four-figure table looking for sine 43 degrees. 43 degrees will give you 0.6820. Then example C, where we have tan 251 degrees. So tan 251 degrees falls in the third quadrant. That is angles between 181 to 270 degrees. So 251 falls in the third quadrant, where the formula is theta minus 180 degrees. So that is 251 minus 180 degrees, which will give us 71 degrees. And in the third quadrant, tan is positive. So that will give you plus tan 71 degrees. Then from your four-figure table, check tan 71 degrees. Tan 71 degrees will give you 2.9042. Then example D, which is sine minus 58 degrees. This is a negative angle, and which you are going to read your angle in a clockwise direction, and which will fall in the fourth quadrant. So the first thing I will first do here is to return this minus 58 degree back to a positive angle. How? I told you in the previous example that if I have minus 58 degree, then the best thing I'm going to do there is to subtract it, to add 360 degrees to it. When you have a negative angle, you add 360 to it. And when you have a positive angle, you subtract 360 from it. So here, I have a negative angle which is minus 58 degrees. Then subtract it from 360 degrees. So that will give you 302 degrees. Now, 302 degrees falls in the fourth quadrant, which is still the same thing as minus 58 degrees. Because when you are reading an angle in a clockwise direction, that will give you a negative angle, which we start with from the fourth quadrant. And in the fourth quadrant, sine is negative, because only cos is positive in the fourth quadrant. So sine is negative in the fourth quadrant. So that will give you minus sine 360 degree minus 302 degrees, which will give me minus sine 58 degrees. Then checking from your fourth figure table sine 58, that will give you 0.8480. Then because your sign is negative, that will give you minus 0.8480. Then the example E, which is tan 1 minus 145 degrees. So checking 145 minus 145 falls in the third quadrant, reading the angle in a clockwise direction. So that will give you minus 145 degree. Then you add 360 degree to minus 145 degrees. So that will give you 215 degrees. So then it means I have tan 215 degrees. In the third quadrant, tan is positive in the third quadrant. Tan is positive in the third quadrant. So I have tan 251 degrees. And don't forget, in the third quadrant, the formula is theta minus 180 degrees. So that will be 251 degrees minus 180 degrees, which will give us tan 35 degrees, where my tan is positive. So that will give me plus tan 35 degrees. Then checking the value of tan 35 from your fourth figure table, you have 0.7002. So my final answer will be plus 0.7002 for tan 35. The last example, which is cos 33 degrees. Now, cos 33 degrees falls in the fourth quadrant, whereby I told you first. Now, here I'm given a positive angle. You just subtract 33 degrees from 360 degrees. When you are given a positive angle, you subtract it from 360 degrees. And when you are given a negative angle, you add it to 360 degrees. Now, if you are given cos 33 degrees here, you will subtract that 33 degrees, because 33 degrees is already positive. Subtract it from 360 degrees. That will give you 327 degrees. And if I now have cos 327 degrees, so it means cos is positive in the fourth quadrant. So that will now give us the formula in the fourth quadrant is 360 degrees minus theta, which is 360 degrees minus 327 degrees, which will give us cos 33 degrees, which will give us 0.8387. Or you can do it directly. Since the angle is already an acute angle, just check. 33 degrees falls in the first quadrant, where all three ratios are positive. So it means cos will also be positive in the first quadrant, which is cos 33 degrees. Then check your fourth figure table. Cos 33 degrees, you have 0.8387. So this comes to the end of our class for today. And you have 5 class activities here, which I'm expecting you to submit by Friday, latest by Friday. So you have question on angle of elevation and depression using the trig ratios that we have done before. Don't forget, you have to still go and try and recollect and memorize the special angles, which are the trig ratios, the sine 30 degree, sine 45 and sine 60, cos 30, cos 45 and cos 60, then tan 30, 45 and tan 60. And today we also did something on quadrants, whereby we have the first quadrant where all the trig ratios are positive, and in the fourth quadrant where only cos is positive, the rest are negative, and in the third quadrant where tan is positive and the rest are negative, and in the second quadrant where sine is positive and the rest are negative. So for the class activities, you have 5 questions, where question 1 is talking about angle of elevation and depression. Then question 2 is talking about decide which quadrant the following angles lie in. So you tell us the quadrant in which these values are. Then the question 3, express each of the following negative angles as its equivalent positive angles between 0 degrees and 360 degrees. So you state if these angles are positive or negative angle. Then question 4, find the values of the following. Sine 110 degrees. So you give us the value. Then the last question, express each of the following as an angle which lies between theta and 360 degrees. So today, this is the end of our class for today. We shall be meeting on Saturday for our normal class assessments. So good day.